This conference will now be recorded.
Yes.
Okay, thanks. Okay, thanks for the introduction. It's good to hear your voice again. It's 18 months since I left Swindon with the opportunity to go over to work on the Federal Way project. There's two roles. It was professional head of North America for track, so I still retain the track element, but also to be the sort of engineering manager on this large Federal Way extension project. So I've got a few slides to put together, well, quite a few slides to put together. Let's hope the broadband in the home here, well, thousands of miles away, holds up. And if you bear with me, if I have any problems, I'll try to work it out remotely. But the project I'd like to take you through is basically, we've got a client. It's Sound Transit is the client, and they were back in 1993. They were put together, but basically history. In 2024, the new network is going to be updated. In 2035, I'll take you through the fact that what the future of the network is going to be over here in the Pacific Northwest. I'll run through then the background and overview and what I've been involved in on the Federal Way project itself, and then I'll allow it's probably best to do questions after, as he said. So the client. So I'm based in Seattle. Here's a map of, let's just do this up here. Typical weather is exactly the same as it is in England. It rains a lot. We've got next to the coast. It's all what it says. If you've ever seen Sleepless in Seattle, it's exactly like that. So if you don't like the rain, don't come to Washington. But in 1993, the local authority at Washington got together and to create what they called the King County metro system, and thought that they needed to overcome the problems of traffic and the amount of cars, because the Americans love their cars and the cars are huge. So they got together, put together a plan. It's created in 1993 by King County and Snohomish Regional Rapid Transport System to deliver a system that could run in 2000 and opened in 2019. Now, the annual ridership is typically 23,000. I'd just like to point out that there's two famous things in Seattle. We've got the Seahawks, famous for the American football, and the Space Needle. So whenever you come to Seattle, they're the two main drivers. And it was for that reason that they wanted to get the network system working here, so they actually could connect people to get to Washington easier without the need for traveling by train. So they produced the new train system. That's it. Which was about 62 fleets vehicles running, and that was try to remove the associated traffic impact. The speed of the trains is 50 miles an hour, and this principally only ran from Seattle. It went north up towards the northern sector, and down south heading down towards Tacoma, which on the coastal line. So it was only basically a north-south ride, but it was interoperable. So it was built on the same gauge as the National Railway. It operates a weekly service then along the two corridors that radiate outwards for the King County. And the expansion in November 2008, they realised that this wasn't enough. So the voters approved for additional local funding of a new 15-year construction program of the light rail network in Washington. And in November 2016, the South Transit approved a $54 billion plan to improve and expand the mass network in the Seattle area. So you can see the expansion, proposed expansion from what it was, going out east-west and north-south extensions. Now, by 2024, the Sound Transit will more than double its system, with about 37.7 miles of new track coming online over the next 4 years. And this track is a sort of a metro system, so it's on a slab track, or some of it is ballasted depending on the whether it's at grade. But it's all new structures, all new stations coming online. The listed projects are currently in construction here. So we've got Northgate Extension, which takes us up this way. We've got Tacoma Extension, which is down to the south. Then you've got the Linwood Link, which takes us over the sides. So a lot of ones. And the one that I'm particularly driving as the engineering manager is the Federal Way Extension, which is this section here. Takes us down from where there's no existing track at Angel Lake through to Federal Way. Now, the future expansions are in various design stages. We've got some of these preliminary designs going on. Some are in initial planning, but there's about 54 miles of track that's going to be expanded up until up to 2024. Sorry, 2040 from 2024. It is the expansion is quite aggressive, and we've moved from currently what we have now at 20 miles to within 4 years going to have 113 miles. COVID may have a say in that because some of the projects are struggling with budget because we're having to comply with the COVID-19 rules, and trying to construct and have people working closely is causing additional costs. So there is a restraint. Also, the challenge is the restrictions on travel. So the forecast planning ahead didn't take into account COVID-19. So there is less ridership taking place because more people are working from home. So the projects that are up until 2024 is still being delivered. And the future expansion here may be susceptible to change. And I dare say that's the same in all parts of the world. A bit closer look at the project itself. We're going down from where it terminates at the moment, Angel Lake, and it goes all the way down to Federal Way. And you can see it's 7.8 miles long. There's 3 main elevated stations throughout. It's the largest design build project that Sound Transit have produced, and the project was approved back in November 2016. It's an extension of the light rail, as I said, that will take us down and connect Federal Way as a future hub, and then up into Seattle. It's a turnkey project, so it's a design build, and this is the first time that they've delivered a design build. The contract sum was, I think, 1.3 billion. But what they want to do is they want to basically put all the onerous back onto a single contractor, and we, as Atkins, are helping them manage that interface between the contractor and the client. So it's informing the client, enable them to create the appropriate specifications and enable the contract to be delivered, managing the interface and the budget for the client. We proceeded back in March 2020, and it's due to be completed mid 2024. And we are on track at the moment, even though the very challenging time last year, which continues this year. But let's keep it on track, hopefully. So the Atkins role on the joint venture, we are with MOTS, so Atkins and MOTS are put together. It's a kind of an oversight role that I'm involved in. as the engineering manager, as part of the team. It's acting as a client and making sure the design, construction and quality assurance is completed so that they can deliver and operate the railway safely when we hand it back. We have local subcontractors, but the principal contractor on this job is Kiewit, who's fully familiar with the design build contract, and we're working well with them, and we've got a good relationship building. So between MOTS, S&C Lavalin and Sound Transit, we're helping to deliver the design build. Phase 1 of the project was the award, which was back in 2019, and now we're into phase 2, which is the design and construction elements. Just to give you a flavour of the people on the team and the way it's built, there's a chart here which shows how we're managing oversight with the design, how we're managing them with the construction, and then overlapping it with the quality assurance. Now this kind of organisation is a mirror of what Sound Transit have, and interfaces with what the contractor has. So we're acting as a sort of jam between the two slices of bread and making the whole thing work. So we get a design build contract built to the quality. I was going to show you a video, but I think I was a bit concerned when we did a trial that the broadband may not survive. So I've taken some snapshots of the oversight, the aerial view of the route. There are some complications, but it starts in the north, Angel Lake, which exists currently, and we're connecting into Angel Lake, and we're doing an elevated construction that has to take into account the future proposed 509 main link road. So we're integrating that, which is going to be built after the design of after Angel Lake is built and after the main construction through route of the 7.8 miles is built. So it has to take due cognizance of this proposed. So we're dealing with what we have here as the agency is WSDOT, or Washington State Department, and we have many third parties that we have to interface with to make sure that we're not disrupting, and it's all working as a system, transport system. So I'll just take you for a few slides, next few slides, which will run us through the overview of the project. As we come further south of the 509, you'll see that the route alignment takes a parallel running with the adjacent I5 motorway, so that's equivalent to the sort of M4. And there are various structures that we have to build, and we've got the underbridge here, 2/16, which is kind of 200-foot long underbridge, so it could be deemed a tunnel. I've got some more detail on that. But that then runs parallel as we go down to the first station, and we come down to what is Kent Moines station. Now this is where it's not only a route alignment project, it's also a redevelopment project. So it's redeveloping the area all around the stations where they considered it to be run down, and taking it as a regeneration project. So that's why we've got highway, not only the highway authorities involved, but we've also got what we call the AHJs, or authorities having jurisdiction, and Kent Des Moines is one. That's like probably boroughs, yeah, it's a Swindon borough. And then we go through. So there are many different types of interfaces that we have to keep through. On a more technical level, we've got the challenges where we're running further down the alignment, following the I5 corridor. We have Midway Landfill, which is a historic landfill site. So it's got leachates, and we do not want to break the liner through there. So we've had a lot of interface on how to design through there safely and make a cutting, so that we don't have future problems from an environmental aspect. Also in the northwest here, in Seattle area, we've got a lot of wetlands. As I mentioned earlier, it rains a lot here, and it's quite low lying down by the coast. So we have a lot of natural wetlands that are permanently saturated. So we have to build structures to accommodate that sort of saturated land and get over the geotechnical problems, so that we don't have a potential problem with settlement. Additional to that, we've also got the challenges of liquefaction of the subsoil, because this area is susceptible to earthquakes, and everything that we build has to be constructed to earthquake guidelines for this particular area. So that's another consideration into the design. And as we move further south, we get to Star Lake Station. This is a new station and a new area that's being redeveloped with the car parking. So every station hub is going to have a large car park. They call it a garage over here, but it's a car park in principle. And the route alignments into it from the road have to be designed, and the landscaping has to be completed to the northwest architectural requirements, and therefore everyone has a say. So it's making it quite slow progress in design, but we want to get everyone approved, because we can't go to construction, we can't start construction unless we have the washtop, the authorities, the client, and the contractor all aligned with the agreement. Moving further south then to the end of the alignment, so we're down here around about 8 miles further down, we're redeveloping the whole area of Federal Way. So a lot of that land, there's a lot of purchasing of land that's been done quite a few years out, and it's coming in here. You'll see the alignment comes around to Federal Way. It's on an elevated structure, and it finishes at the Federal Way terminal. This then becomes the starting point for the future extension. So we've had to build that alignment to cater for 2 speeds. So it comes in at 5 miles an hour to sort of stopping, and then it's going to be a through route connecting further south, well, I suppose it's southwest to Tacoma, where it will come through at 50 miles an hour. So, and the idea was to design it such that we could have 0 elevation, and then the plinths could be shimmed so that they could be taken out, and the permanent elevation would be the 30 mile an hour through route. So that's some of the challenges we were coming across. But that's an oversight of the sort of route, and to give you a sort of heads up. Looking a bit more detail then as we go through the disciplines. In terms of track, and I suppose this is what you guys are probably more associated with, majority of it is going to be on sort of elevated track with concrete plinths and appropriate barriers. These are standard spacing on these base plates will be 760, so that's sort of typical for a sort of Pandrel or an Eclipse style. We're not over-egging the spacing arrangement. The at-grade would be ballasted track on what they call concrete ties here, but they're very similar to the concrete sleepers you have in the UK, in Europe. Gauge is 1435. The rail inclination is slightly different, it's 1 in 40. And the rail type profile is 115 RE, so it's slightly bigger than 113A or 13-pound rail. And it's fast clips, but it can be interchangeable with Pandrels. That's it. So in essence, it's very, very similar to European track on this metro system. Now, I mentioned earlier some of the problems we were having. And I mentioned the landfill site and the interface with the I-5 on the left. So if you look at it here, I've got a cross section here where we've got the I-5 motorway, highway, they call it here, running down this side. So the drainage is being taken away here from the I-5, but also we've got the landfill site. So I've just blown up this section here, and you can see we've got the landfill all through here. So we're building a retaining structure to hold that back, and then a liner to stop any leaching and getting anything bad from the landfill site into the watercourse, and then designing it such that we can take the water away from there and drain away. So there is a large drainage, there's a whole system package here really to how do we deal with one problem on the right hand side, and we've got no way we can get the water away to the motorway. So it's a combination of solutions and then hydraulic modelling to prove that the design would work to allow no more future sort of ponding of water in this area. So that's been quite a challenge, and also the treatment underneath. So if the track alignment is here, we've got variable, let's say, sub-based materials here. So it's treating that to make sure we had the appropriate bearing capacity for the actual land itself. The sort of typical track, there's only 12 S&C units on this, so it's not a lot of crossing of the tracks. It's basically, you know, it's a metro system for getting from one station to another, stopping at all stations. So the only areas that you'll have crossovers are to allow for operational movements, maybe a maintenance at night or coming into sidings. And so there are 12 S&C units added to this. Typical design speed, as I said, was 50 mile an hour through route. Turnouts of 20 mile an hour into sidings. Everything's electric motor points, and it's fully welded track, you know, CWR. So track is one element of it, which seems to be everything standard componentry. If you're pulling it in new, you put it in on the straights, you won't put it in on curves or high canted track, you won't have tight radiuses. So we've had the freedom to produce an alignment, or review the alignment, I should say, to make sure that it's maintainable and they're not having future problems. We've also integrated into it as rail grinding strategy that needs to be delivered, or rail polishing, so that the contractor is having to meet after he's installed it to make sure that we keep the profile of the rail, both the switches and crossings and the plain line, in good order. Now, I mentioned earlier we had the challenges with the civils and structures, which was the tunnel alignment and the future road that we had to take into account. Now, it was the seismic problem where they put a interlocking sort of box through the underbridge there first, but couldn't prove that under seismic conditions it wouldn't disengage. And so what they've come up with is a cast in place. Well, it's cast, and then it will be walked in or wheeled in place. So it's a complete unit. So it's important that the geotechnical information that they had was accurate enough so that this was a very rigid structure, that it wouldn't crack under installation. So the biggest problem was proving that we had they have the rigidity in the box in its weakest state when it's being installed. And then settlement afterwards would be comparable. So I think we're trying to put it in within about 50 mil tolerance over the whole length. And if we're outside of that tolerance, then we could have trouble with the box itself cracking. Similarly, well, we've got the typical layout element of the columns. These were, there's thousands of these columns going in along the route. Now, they're all being constructed on site and predominantly, well, all through the elevated structure. Yeah, there is a real concern over the thermal performance or thermal monitoring. So there's a thermal control plan that's put in place here, and you can see the sensors. So when they're pouring the concrete, casting it, they're monitoring the thermal temperature internally and externally, because we get high winds and high rain. It can affect the rapid cooling of the concrete. So we have to make sure that the plan in place when they're curing these doesn't give us a sort of a thermal shock to the concrete, and therefore the column becomes weak, fractured and obsolete. But we've got it down to a kind of a rolling program. It's like a factory line where they'll be piling, getting the settlement right, getting the position of the shuttering correct. In parallel, they're getting the casing corrected, and then they've got these reusable shutters. Yeah, and then they'll be pouring the concrete, curing the concrete, and then they're moving on. And they've got this rolling program that keeps going until they can remove the shuttering after the dedicated time allocated in the thermal plan to give them the confidence that the concrete is safe and sure. With regards to civils and structures, I can give you a quick flash update. The design is about 85% complete. In terms of construction, so the design from basically the civils, I should say, is 85% complete. Some of the structures in the stations and garages are further down the line, but they are progressing. We work under a similar GRIP process that you used to have in the UK. I don't know with Brexit whether the GRIP process is changing, but we work off a 30% design, a 60% design, and then what we call a 90% design, and then it's the IFC or 100%. So there's that staged approach the designer has to go through. And as the design matures, it gets more complex and more detailed until you get to approved for construction drawings. So in terms of the challenges, base contract, we're about 25% complete. Yeah, demolition, a lot of the felling of trees has been done and clearing and grubbing. Big challenges on relocation, working with Puget Sound Energy, where they think their utilities are, and when you actually go to do trial holes, you see some, but there's a few things that are catching us out. But I think in every project I've worked on, utilities are a challenge. There's the excavation embankments. This is the route alignment going in next to the I-5, where we're just monitoring embankment stability when they're working and making sure that there's no issues, and also when the day times that they can actually work. When there's heavy rainfall here, they can't be excavating. And the two complexities, as I mentioned, is Midway landfill and the liquefaction. So we're constantly keeping an eye on these two things to make sure that we don't have a safety hazard on site. And we have a full-time team reviewing quality checks for safety as part of the requirement under the contract. So moving on to stations and garages, we've got, as I say, 3 main stations. We have Moines, Star Lake, and Federal Way that are integrated into this over 8 miles. So it's only every 2 miles or so you'll have a station, because it is principally for people to use as a quick commuter route in and out of Seattle. There's a few challenges on station. I think it was Star Lake. Yeah, it was Star Lake, this one. So we had a derailment risk. What happened basically, they put an elevator too close to the edge of the platform, and then the rulings in this state of Washington is, if this train derails, what's the consequences? And if it's too close, and this was less than 3 feet, so it's a very narrow entrance at the top end. We reviewed potentially to go for a deviation to the contract by checking the rails and stopping the derailment, but the consequences of hitting this would take down the building because it was a glass facade, and therefore we had to widen out the structure and get allowance so that we had the clearances, or the designer had the clearances for Star Lake. So there are a few challenges with certain stations. So I'll just give you an overview. Kent Des Moines, we've got Kent Des Moines station here. This is where the new parking's going and the route alignment through, but there's a lot of emphasis being placed by the authorities having jurisdiction that the landscaping is done to their specification. It also allows for about 500 cars spaces here, and it's promoting easy access from the train station to the cars or to the open landscapes. And we're having 2 large sort of plaza areas where it's open art. There's going to be open art here, and it's going to look nice. I'll show you a picture next, actually, of what it visually is going to look like. So this is the sort of artist impression as you see the station, the roadway through there, and how they're going to landscape it. So it's going to look, I think, quite smart when it's finished. Similarly, we've got the Star Lake station. That again is a similar layout where you've got the station line coming in, you've got the large car parking area and the planting with lake beside it. This also has 500 car spaces, 3 new landscaping areas and 2 plaza areas for seating and public. So it's a similar footprint. And this is an artist's impression of what it would look like. So as you're walking from the bus through to get your tickets, and then the train station on top with the glass facade. We've had to do, anywhere we've got a station or garage, we have to go through the Washington Energy Code, and every structure has to be approved to their energy code. So we don't want buildings that have potentially got cold spots. And they're modeling this in sort of a 3D environment to prove that they will work in the environment of the Washington state. The challenging one was the terminus station at Federal Way. This is, I say, it's draft still. We've nearly got a solution, but this is a complete redevelopment of the whole area. It's not just the station. So there's the station as it comes in. There's an extension of the existing garage area or parking area, and then the road structure around here is being remodeled as well as part of the project. And this sort of an artist's impression of what it would look like. So you'd be parking out the front, you have an elevated Federal Way station, and shops and interfaces underneath. So that's the sort of 500 new car parking spaces again, new street access, biking, and 2 plaza areas. So it's a similar footprint again. And these are sort of coming towards 90% of design. So we're at the detailed analysis, and we're at the thermal modelling plan to prove that they meet Washington state codes. Moving forward, other considerations we had the environmental considerations. So big impact was looking at this thing here. It's the noise and vibration effect of having a rigid concrete structure running by your property. Yeah, and so the whole route, or the extension, had to take into account the operational running of the trains. Yeah, so the frequency. What we terminate here as a headway. So I think we're working on a 6-minute headway between trains. So it's a high frequency running service, not running fast, but it's running concurrently northbound and southbound. And that analysis had to come up with, based on the route alignment, based on the speed, based on the construction, whether it was ballasted track or unballasted track, whether it was on a floating slab or whether it was on a treated mat, had to be taken into account to give us a sort of a decibel frequency of noise. And then we had to assess how far away the building or the impacted building was, and whether they would need mitigation along the route. So that was one quite large area which we finalised, it was only a few weeks ago, to give us the noise wall construction heights verified along the route. The other things that we were looking at was there's a mass of concrete being used on this project. So we're looking at the carbon footprint of the project. So we switched, because the suppliers were switching to an L1 cement, so L1 type 1. We had to get approval of the type 1 cement for durability for 100 years. So it's the design life of 100 years for the structure, and making sure that the concrete would last, and that report was approved a while ago. So we're helping with the carbon footprint of the world with the masses of concrete we're using. We also were recycling a lot of materials. There's a lot of woodland. This was being regenerated and chopped down. Also recycling some of the backfill. It's being griddled and reused where possible. So the specifications were redrafted to account for that, and to allow to sort of reduce costs but not reduce the quality. And the protection of the existing wetlands was also important. Yeah. So it's if I say here, it's noise, visual effects, it's the construction, security, and traffic details. All these had to be taken account of in the design process, as well as the wetlands, protecting the existing route, existing infrastructure. So the impact was deemed minimal, but the benefits of the project were seen as beneficial. I think that's where I'll draw it to an end. Yeah, and I'll say, has anyone got any questions? They can, I don't know how to take them, but thank you very much. I've enjoyed the 18 months so far, and I've got another 2 or 3 years to go to build this before. And if I can get back to the UK, I'll try to, but at the moment I can't travel. So, but I'll say thanks. Over to you guys.
Thank you, Geoff. Thank you for this presentation. I will ask the first question with regards to the design. Considering how complex this project is, I presume that the integration of all the disciplines is quite essential.
Yes, I'll use this one.
And I was wondering, from the point of view of the software that is used for track, which software is used there, and how this integration of the track with the other discipline is managed there.
Yeah, so they use Bentley Railtrack here as well, and I think moving forward, Atkins, I'm trying to instigate that every part of North America uses Bentley as a company. So we are moving that way, and that's what we did in the UK for Atkins. So that's the decisions being made, but it does, because we've got 50 states here. Some states will have their own requirements, and it's for us as designers or to make that decision. But we have what we call an ICD procedure, so an integrated control diagram, I think they call it, where the designer has to prove where the interfaces are and demonstrate that they've mitigated the risk. So we have a preliminary hazard analysis. So if they notice, say, I'm just showing the screen here, if there's some sort of construction hazard or if there's a design risk, they have to put it in their submittal as part of the overall central risk analysis. And that has to demonstrate how what the risk is, what the design has done to try to mitigate that, and what the residual risk is, because where the client, we're acting as the client on behalf of the client, is what is the residual risk that the maintainer has taken into account, and is that risk feasible to consider as standard? So that's all part of the submission under the preliminary hazard analysis. It's very, very complex, and I probably won't go into the details of it for systems and stations and garages, where they go down to quite a lot of detail about how they are, let's say, meeting the contract obligations through the preliminary hazard analysis and the various documentation they have to use to prove that they've mitigated the risk. I think that's a succinct way to try to. In terms of modelling, there is a central model, and they reference in. So we're using, say, Bentley as the alignment. Once they've got the first thing that was approved, probably about a year in advance of everything else, was the track alignment, and then the track alignment was frozen. That track alignment then was used as the baseline for the structural elements. Unless there was I don't think there was any really thing. No, that was it. It was the elevation that did change in a couple of locations due to the, let's say, the more mature details that we had from the geotech related to, let's say, unstable soil conditions. So that's why a lot of this couldn't be laid level, and some of it had to be elevated off, as you see in the picture here. So you've got an elevated construction. So,
Okay.
any other? it sounds like I haven't got any more questions. So I've either stunned you all or you've fallen asleep. But I must say that I've...
Sean Marie is asking, noting the environmental effects, is the project undertaking environmental assessments?
They are doing yes. At the start of the project, there's a whole team that are looking at the environmental impacts, yeah, which is principally being led by the client, yeah, and making sure that they're following the regulations, yeah. I haven't been involved in the detail of the environmental legislation because it's kind of client-led. I've been more involved in the alignment and the structure and the building of it. So, but the appropriate regulations, impacts, every specification that's been modified, because we work under a division, they have a tier system of specifications here. So it's like what are equivalent to standards in the UK. Well, client will own a standard and they will instigate that as part of the contract. That can't be changed and only be changed by approval by the author. And the appropriate specs have a specification owner. Now that will be, and there is environmental in that and there are structures. So it's making sure that they're compliant to the specifications that are referenced in the contract that meet the obligations. So we cannot, you know, there is certain rules about replanting, there are certain rules about, in terms of the felling of trees even, there's trees that are set aside that can't be rooted. If they do have to remove a tree for temporary works or whatever, then there's a replanting process that needs to be done. There's also the wetlands is a big thing about disturbing or fouling into any of the water courses that are down there. That has to be validated. So there is, I would say, probably it's greater the amount of interface that we have to do with the environmental on this side from my first impressions. And it plays a large part because they're quite protective about their, you know, if I just go to this slide here, you know, the wetlands here, you know, we're putting a route alignment all the way through there. So even the temporary easements that you get, so we may have temporary easements along here. What I mean by that is temporary construction rights, but that then is allowed to enable you to get construction, but then these then will be retracted back to the permanent line markers. So there's a lot of, every parcel of land has an owner and a requirement that you have to manage. And all these areas are all parceled off. And so there can't be one parcel of land that's affected without the owner or knowing about what's to be done.
Matt Weber has a question.
Yeah, hi Geoff. It was just a question around the design for the seismic risk. Obviously, you didn't really have to design for that over here. What does that you know, comprise of? How does that work? What are they actually? What are the structures actually better able to do than they would be in the UK?
Well, I mean, they've got to take the shift. I mean, what's happening here? If you've got material that's susceptible to liquefying, and they've found that, so that will mean it loses all its stability. So that you've got to either, you can't leave it and say, right, I've got the foundation, but it's going to be in a potential soil that's going to liquefy. Yeah, so it's going to turn to liquid, say, for simple sake. We have to either bridge it, which is an expensive way to do it, or we treat the soil. So there's solutions that they're having to go through to prove that it's a sort of a, you know, maybe a 1 in 40 year life cycle of a risk, but it could be one in terms of a quake, they go up to hundreds of years. The actual probability is less and less. but in certain locations, you have to overlay your route alignment with the hotspots for earthquakes. And there's 1 or 2 areas that are in hotspots, and then related to that area, the code you have to design to. And if the consequence of the earthquake could mean that the soil is susceptible to that frequency of earthquake, then you have to treat the soil or bridge over it. Is the basic terms that we're using, but not all parts of the alignment is affected by that. So it's important that the geotechnical information picks up the soil type, and they're designed to that geotechnical information. I think that's as simple as I can put it.
Oh, that's great. Yeah, thanks for that, Geoff.
Okay.
Joel Worthington has a question also.
Hi, Geoff. Great presentation. I was just wondering, now that you've had a couple of years, what do you think you would take back into the UK and say we should be doing more of this?
I mean, I actually think the UK are ahead. I mean, in terms of their design processes, what I've found, because what I've had to drive here is the integration, design integration, and the risk mitigation is what they are still going up the learning curve on. If I go back to what we did in a project over at GWEP, the Great Western Electrification, the sort of risk mitigation and risk log, and the management of introducing an OCS system or an OLE system over there, it was, I think, more comprehensive. They're learning in the States here on how to design and integrate. So we're giving them a lot of steer on what to do, in addition to what's the basic requirement. So I think maybe because I'm English, the UK are slightly ahead on the way they design large projects. This is, bearing in mind, this is the first project in rail that Sound Transit's ever done as a design build. Also, rail isn't big in the US, so, and it's what, 50 times the size of the UK with the 50 states. So skill base is quite low. So they're interested and using consultants to help them deliver. This is clients deliver, and the contractors are more associated with design build, but not necessarily they've got the skills within the rail, because it's quite low in the US. So I say we're there to help them go up that learning curve, of which there is, as you showed at the start, there is quite an expansion and interest, because they're trying to move the love of the car away from the Americans, because they seem to love their car, but it's clogging up all the cities, main cities, and Seattle's getting kind of ruined by complete congestion, and introducing this sort of network into it is the way in which, and then integrating these networks to the high-speed links, making them nodal, is what they're planning to do in the next sort of 15, 20 years with the high-speed rail links. Okay.
Yeah, great, thank you. I guess they don't have a CSM process, do they? So that's sort of what you're saying you're introducing.
We're introducing, yeah, that's right. They don't know, but it is a risk mitigation. It is more traditional what they were doing, but we were actually putting it together as an ICD, an integrated control of the model, and then proving how you've mitigated the risk, and then issuing that as part of the hazard analysis review, so that the client can take on, I think they call it the SIMS log, which is the residual risks. So they're fully aware of what is what was built, what was designed, what was built, and then what are the residual risks to take into maintenance. So we have, what I haven't said, we've had the maintainer, so the Sound Transit maintenance teams have been on and through the design. So all the way through, they've raised issues about operations and maintenance. So this was built with them in mind because they're the ultimate client for Sound Transit to operate and maintain the railway, and they will bring to the party their requests. We have a requirements list though that we have to deliver, and we can't just add variations in at a whim. But if it can be integrated to the design as the design's progressing at $0 change, then that's what we were doing. Okay. I don't see any more questions coming up.
I think this is it. Yeah.
That's good.
Thank you,
Okay.
Geoff. Thank you for giving this presentation to us. I hope we'll be able to see each other again face to face very soon.
It's a funny time, isn't it? Yeah. Travel and stuff. But yeah, once I've got my green card and I can fly in and out of the country, because I won't do that at the moment because I may not be allowed back into the States with COVID. And so I'll probably see you, but we'll keep in touch. I mean, if I can give an update again in the year's time and probably show you more actual build than what I've shown here as a model.
Yeah, that would be great.
Do you want a copy of this?
Yes, please. Yeah.
Yeah. Okay. Well,
Okay.
I'll slightly.
Thank you, everyone, for. Sorry.
Yeah. So you carry on.
Yes. Thank you, everyone, for attending. With this, we are ending this presentation here. See you next month.
Okay. Thank you.